Alright, second day of 7.3. I'll look at two problems to help you out today. Going to take a look at just another example of solving using the row echelon form or Gaussian elimination, where you run through those particular steps to solve for x, y, and z to get that stair-step pattern. And then the other one is, what do I do when I get a system where I have more variables than I do equations? Alright, so those are the two problems I'll look at for today. Alright, so the first one. Remember what your goals are. You want a 1 in front of one of those x's. Well, you want to try to look at combinations. Unfortunately, the 2, and the 6, they all go into each other evenly. So the only way to get a 1 in front of one of these is to simply divide, which normally you don't want to do, but that's kind of why I picked this problem. I want you to see one when you have no choice. If there had been a 3 in front of this x, well then I would have said 3x minus that 2x. Or if there had been a 5 here, I would say it's 6x minus 5x, or some variation of that. Alright, so now make it easy on yourself. If I divide this one by 6, I'm going to have a fraction. That would be okay, and a fraction, so that's 2 fractions. Divide this equation by 2, that's okay, there's a fraction. Divide this one by 2, I have fraction, fraction, fraction. Looks like this second one is probably the best option. So I'm going to rearrange the order and I'm going to divide that by 2 kind of all at once so I can save myself some steps. So my new first equation is going to be x, remember I'm dividing by 2, plus 3y plus 4z that will become, and then it's going to equal 3 over 2. Again, I have a fraction, but I can't avoid it completely. Alright, then I'm going to write down the other two. So again, make sure that you're writing down steps. I am multiplying 1/2 times row 2 up here. Alright, then I'm just going to write down row 1 and then row 3, doesn't matter the order. So it's 2x plus y plus 3z is equal to 1, and 6x plus 8y plus 18z is equal to 5. Alright, so there's my kind of first part of the step one. Is I got the 1 in front of this x. Now I need to get rid of these two. So again, copy down that first equation. I'm going to go ahead and give myself the rectangle right away. And I know I need to multiply that by -2. So I'm going to say it's -2 times row 1 plus row 2. And so then I'll run through and do that algebra. So it's -2 plus 2, that gives me 0. -6 plus 1, or -5y. Looks like it's going to give me -8 plus 3, or -5z. And multiplying this by -2 is going to give me -3 plus 1, or -2. So be careful with the fractions. If it takes you a second to kind of maybe show your work, do that if you need to. Alright, then I'm going to have to multiply the top row by -6, add it to the third row. So -6 plus 6, it gives me 0. That's why I picked -6 in the first place. That's going to give me -18 plus 8, or -10y. -24 plus 18, or that's going to give me -6z. And then multiplying this by -6, it's going to give me -18 over 2, or -9, plus 5, or -4. Alright, so goal 1's accomplished. I got the x, I got rid of those x's. Goal 2, get one of these to be a 1 in front of the y. Unfortunately, 5 goes into 10, so this is another one of those so I can't avoid it. I have to divide. And I'm just going to divide the second one, because it'll give me less fractions. So again, keep the first equation the same, don't change it. Second equation now, I'm going to multiply, or I guess I'm going to divide or multiply by -1/5, however you want to write that. That'll give me 1y plus 1z is equal to +2/5. Make sure you're careful with every little detail, including signs, because having that being a negative, it's a very minor detail, but it will mess up the answers quite a bit. Alright, I'll still follow your work through, so I'll still know if you're on the right track, but it just might make things a little more messy. I'm just going to keep that equation the same, or a lot of times what I like to do, if I can do it quickly and I can here, I'm going to combine and do 2 steps. I'm going to get the 1 in front, and remember, whatever I write down here is referring to this. I'm going to multiply that second equation by -2, which would make it +10, and then add it to the third row. I'm going to kind of combine 2 steps at once. It just saves myself steps, so I don't have to constantly write out these things. Alright, that's going to give me +10, -10, that gives me 0. Of course, that's why I did that. -2 times -5 is going to give me 10 minus 6, so 4z. And then negative 2 times negative 2 gives me 4 plus 4, or that's 0. And then once you get down to this step, instead of writing out all of it again, you can just say that z is equal to 0, or whatever number you get there. And then start back substituting. If z is equal to 0, well, that makes this one easy. That means y is equal to 2/5. And back substitute to the top equation. It's x plus 3 times 2/5, or 6/5, plus 4 times 0 is equal to 3 over 2. So I have x plus 6/5 is equal to 3 over 2. Going to have to get a common denominator and subtract. So my common denominator would be 10. Subtract and then multiply by 2 over 2. That would give me negative 12/10. Plus, multiply by 5 over 5, that's 15/10. Or it looks like x is going to equal 3/10. And so my answer for this particular problem is 3/10, 2/5, 0. And that will solve that system of equations. And if you're doing a problem like this, it's so easy to make little mistakes. You have to be careful, and if you make them, you have to understand the difference between I made a little mistake and I got it wrong, and I have no idea what I'm doing and I got it wrong. If you, for example, have a plus sign right here, that's going to throw this number off, which is going to throw this number off, which is going to throw all your answers off. But realistically, you know what you're doing. You made a very little mistake, but you have the process down, and that's important. So again, be able to tell the difference between, yeah, I made a little mistake, that was supposed to be positive, or it was supposed to be -3, or whatever the case may be, as opposed to, I have no idea what I'm doing. I don't know to get rid of these. I don't know to get the 1. I don't know to get rid of this. If that's the case, then you have help. You need to come in and ask for help. All right, the second one is, what do I do when I have more variables than I do equations? For me, that's good news. I know automatically this is a many solutions kind of an answer. This is going to be one of those where you have z equals z. You're still going to go through the Gaussian process and try to get a 1 in front of the x's and then eliminate the x's and so on. Your stair-step pattern will be a little more shallow, I guess. You're only going to have, well, you'll see. So let's go ahead and just divide this by 2 since those go into each other. So that's going to give me x minus 3 over 2y plus 1/2 z is equal to -1. And then I'm just going to leave the second equation alone for right now. So, well, let's take that back. Again, tell myself what I'm doing here. Okay, multiply by 1/2 or divided by 2. Since this is quick and easy, I'm going to go ahead and combine these steps together. I'm going to multiply the first row by 2, add it to the second so I can get the 0 that I'm looking for in that position. So that gives me 4, -4, or 0. That's going to give me -6 plus 9, so 3y. That would give me 2z plus 0, or 2z. And that will give me -4 plus 7, or 3. All right. I've got the 1 here. I got rid of this. My next goal is to get a 1 in front there, and since it's the only equation I have to work with, I have no choice but to divide it by 3, whether it goes into all those numbers or not. So I'm going to multiply second row by 1/3, and that's going to give me 1y. It's going to give me 2/3 z, and we get lucky here. It's going to end up giving me 1. And now I still have that stair-step pattern, even though it doesn't go all the way down to z. I have the 1, nothing here. I have the 1, and then I'm kind of done. I said I know just outright going into this that I'm automatically going to have z equals z. It's not down here, but I kind of know that this is z equals z, and then start back substituting. If you put z in for z, it doesn't change it. You would subtract to get y is equal to -2/3 z plus 1. There's the y answer. And now to find x, I have x minus 3 over 2 times y, which is -2/3 z plus 1, plus 1/2 z, which is z, is equal to -1. So plugging these two things back into that top equation. And now simplifying, I have x double negative, so it's positive. That would actually give me 1, so it's plus 1z. Distribute here, I get -3 over 2 plus 1/2 z is equal to -1. I hope that you can work with these fractions, especially since they're easier. If you can't, multiply everything by 2, and you don't have to worry with the fractions. All right, I'm going to add this 3 over 2 to the other side. I know that's -2 over 2. Add 3 over 2. That's eventually going to give me 1 over 2. On the left side, I've got 2 over 2, 1 over 2, or a total of 3 over 2z. And so now when I subtract, I get x is equal to -3 over 2z plus 1/2. And there's x. And of course, write your answer as a three-dimensional point. It's -3 over 2z plus 1/2, comma, negative 2/3 z plus 1, comma, z. And the book, of course, will switch these to a's, but you don't need to. So, big thing, anytime you see a system where you have more variables than you do equations, you should tell yourself instantly you know it's a many solutions type answer, and then run through the Gaussian, and you'll just automatically say z equals z when you get there. Alright, hopefully that'll help you for the homework in section 2 of 7.3.